I don't know. In high school. But I realized recently I'm learning to expand that for my boss, even though, you know, how to use my boss. Yeah, so it's always boss. They're not just small. It's not, you know, it's responsibility and things, and you have to get rid of it. And both of them like this. I'm just like. Yeah. My mom and I were. Oh, no, that's just. She's like, actually. She got just like, she wrote over here. I gave her a ride. I'm good in. I just. She was in the front. She was there, she's been like. When I was just. Is this more tests? Are those more tests or those?
Just one person didn't get this. Rachel Barrett.
I thought about it, but when I'm not. I mean, I gave her a ride. We went to. I was like, you do with me, I have a problem with her. Well, right.
Okay, let's get quiet. Everyone still likes probability. I don't know. In our meeting we had at the beginning of the semester, they told me they took all the probability out except for what we need, but they did. Okay. We did the first three, I think. The fourth one, I don't think there's very much of it on Alex. Where's that? The fifth one. Because they just threw everything together in that section. If you missed Monday or Tuesday, the class recordings are up here under week 6. We covered the first 3 sections.
Thank you.
Section 4.4 is counting rules. The fundamental counting rule is a rule that is used to determine the total number of possibilities in a sequence of events. And I already showed you this when we were finding out how many possibilities there were. You just take each of your possibilities from each thing that you're doing, as long as they're independent, and multiply them together. Tossing a coin, rolling a die. These two probabilities are independent. So if you want to see how many outcomes there are, and that's what the rule of counting is telling us. There's 2 possibilities when we toss the coin, 6 when we roll a die, which gives us a total of 12 outcomes. You can just multiply all those together. I liked this table that I got online because it kind of explains a little. If event 1 is 4 ways, event 2 is 3 ways, then the total ways are 3 times 4. You can also do a cheap tree diagram, as long as it's not getting too large. I mean, if you're doing a deck of cards, you don't want 52 lines. And that's why you need to know the counting principle. If we were making a pizza with only one topping, if there's 3 different types of shell, ten toppings, and 3 different types of sauce. 5 types of cheese. We wanted to see how many different pizzas we could make if we're just doing one topping. 3 shells, 10 toppings, 3 sauce, and 5 cheese. 945, 450. So you can make 450 pizzas. That's the counting principle. I put a couple. Well, we did the toss and roll a coin. Oh, I don't do that. So it wasn't. Okay, so number 2. There are 4 meat, 3 cheese, and 2 kinds of bread. How many ways can you make a sandwich? If you're only using one of each. Anyone? So there's 4 meat, 3 cheese, and 2 bread. If you're only taking one of each, you just multiply them together. You can make 24 different sandwiches. I think it was Wendy's used to have a thing of how many different ways you could make your hamburger. They were doing the same process. Picking a 5-digit password where 0 is included and the numbers can repeat. A digit is only 1, so it would be, sometimes they don't include 0. If it doesn't say it, I would assume they're including it. So your numbers are 0 through 9. And the first one says, and repeat. Even on your phone, if you're doing a 5-digit password, this can tell you how many different possibilities someone would have to use before they got into your phone. When you pick your first one, how many possibilities are there for the first digit? 10? There's 10 because you can include the 0. So 0 through 9 is 10 digits. Since it can repeat, you can pick another 10. And it still can repeat. So if your numbers can repeat 1, 2, 3, 4, 5 zeros. There's 100,000 different ways you can put a 5-digit passcode. So if you tried every combination, you could get into the phone eventually. Any questions on that? How would number 4 change? Picking 5-digit code, we're still including 0, but you cannot repeat your numbers.
It wouldn't be 10, 9, 8, 7, 6.
First one would still be 10, but then whatever we used here, we can't use here because they're not allowed to repeat. And then whatever we used on these two, we can't use here. So if we're not repeating, there's 30,240. Any questions on that? Factorial. Factorial is when you're going down, but factorial goes all the way down to 1. There's a few formulas. 0 factorial is 1. If we were in calc class, we proved that. 1 factorial is 1. And then 2 factorial, you just go down 2 times 1. 3 is 3 times 2 times 1. 4 is 4 times 3 times 2 times 1. It's used in permutations and combinations. Should be in your calculator. Combinations and permutations should also be in your calculator. Even the basic, forgot to bring it today. There's a $10 calculator. Walmart, Target has it in September. I don't know if they still have it. Okay, so if you have a TI-83 or TI-84, the combinations are under math and then go over to probability. The other basic calculators, they actually have a probability button here, and then when you open it, it shows you permutations, combinations. So you don't have to memorize the formula, you can use that. Permutation is an arrangement of n objects in a specific order. So permutation order matters. You have 9 baseball players. How many ways can you organize them in a batting order? Well, the order matters. You want people you know are going to get on base, and then you want someone strong in the 4th one so they can bring all of them in if they haven't already gotten out. So order matters. A business owner wishes to rank the top 3 locations selected from 5 locations for a business. How many ways can they be ranked? Assuming order matters. Oh yeah, we're ranking them, so the order matters. So the 9 baseball players, just like this, you pick your first person, and then you pick the next one. They can't repeat because it's already up. And then the next one. And so on, that's 9 factorial. It's 9 factorial when you're using all of them. But you can get away from the formula, especially with when order matters. Because if we look at the next one, a business owner wishes to rank 3 locations out of 5. So how many can he pick from when he's picking the first location? 5 of them? Now he picked first place. How many can he pick for second? 4. When he gets here, he's already picked 2 of the 5, so he's only got 3 left to choose. So there's 60 ways he can do it. So a lot of these, if you just think of the thought process, you don't have to remember the combination and permutation formula. I do as much as I can without it. I think the thought process is easier to understand, especially when they get more complicated. Here is the formula. Permutations rule, assuming all items are different. N is the number of available items and R is the number of items to be selected. So for this formula, you can't have like 10 of one type of toy and 5 of another type of toy if you're choosing so many of each. Every item's different. And order is important. We did that for this problem. We have 5 items and we're picking 3. You will get the same answer. Here, I'll put it up there. So for this problem, there's 5 sites and he's choosing 3 of them. 5 factorial over 5 minus 3 factorial. Five factorial is 5 times 4 times 3 times 2 times 1. And if you wanted, I mean, this is only going one more, but you could stop here and go 2 factorial. Because on the bottom, 5 minus 3 is 2 factorial. Those cancel. 5 times 4 times 3. It's just the same. Okay. So there's a lot of different ways of doing these problems. Most calculators, you put the 5 first, then you hit this button and put the 3. There are some where you would put 5, comma 3. They write it this way. But most have this. A radio talk show host can select 3 of 6 special guests for her program. And order of appearance of the guests is important. How many ways can this be done? So there's 6 guests and she's picking 3 and order matter. You could do it this way. Or you can use the formula. There's 6 items, she's choosing 3. Now I stopped at 3 because I know 6 minus 3 is 3 factorial. So these will cancel. If you would have done it the other way, which I think is easier. She's picking 3 places. When she picks the first one, there's 6 ways she can do it. Now she picked one of them, so now there's only 5 places. And when she picks one of those, then there's only 4, which also gives us either way. The good thing about the probability chapter is most of it you won't use again.
Yeah.
Now, when some items are the same, there's a different formula. There are n items. You can group the ones that are alike. So this formula is when none of the items are the same item. But when they are, it's a different formula because you have to take each individual group. I think it's easier once we look at an example. Didn't realize I looked one up. Okay. This one I use a lot is with words. How many arrangements are there of the letters in the word Mississippi? So we're using every single letter. We're just reorganizing them. And there's 11 letters in the word Mississippi. Counting them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now there's 3 different letters. There's M, there's they didn't count the M because there's only 1. Technically, they should have. There's an M. I'll show you why they didn't need it. There's 4 that are I's. There's 4 that are S's, and there's 2 that are P's. And so those values are on the bottom. 4 times 4 times 2, the parts that repeat. They didn't need the 1 because 1 times anything is still 1. So they didn't have to put it in there. I think that's confusing though, because then you don't know why. But it was only a 1, so that's why they didn't put it down there. So your total number of letters, factorials on the top, the groups that you have are on the bottom. Since there's only 1 M, you don't need to show it because 1 times anything is anything. Now, when they're reducing these, there is some confusing, if you're looking back at the notes, not notes, but how to do it on Alex. So I would probably take this down until 4 factorial canceled one of them. So 11 times 10, 9, So I went down and I stopped at 4 factorial, and that's why I left this 4 factorial, because then I can cancel. Any questions on that part? Now, on Alex, they were showing 3 going into 9, and they just highlighted them red and then put a 3 here. What they're doing is they're canceling these. 9 divided by 3 left a 3. Another thing you can do, because the order doesn't matter, 4 times 2 is 8. I can cancel with the 8. But that's what they're doing when they put that exponent up here. Like these two, 6 divided by 2 is 3. And then they highlighted these a certain color. We're just canceling them. 6 divided by 2 gives us 3. And then I would take these two. 4 times 2 is 8, which gets rid of an 8. So they're simplifying when you see them numbers up in the exponents. If you're looking at the how to do the problem. And we canceled everything in the bottom, so just multiply across the top. You should get the 34,600 and so there are 34,650 ways of organizing the letters in Mississippi. We'll do another one. Any questions on that? How many ways can we rearrange the word statistic? You should get 50,400. See what you get. S. Okay, so there's an S on there. Statistic. Are you getting the 50,000 and some? Another reason it's nice to use all of these is you can add all of them up and make sure you have 10. Not that you have to show them here. So the ones you would not have to show the 1 factorial. Because they won't change anything. If you're gonna enter all at once, you want to put that in parentheses. You should be able to.
How do you do? Combination thing?
There's your factorial. Oh, so hit your number first, so you would put 10 and then go back into there.
Okay.
You know what, since you have a fraction bar, you probably don't need a parenthesis.
Oh, yeah.
No. So if your calculator will make a fraction bar, you do not have to, I didn't know the calculator, I could do that.
No.
But I learn something every day. If you have a fraction bar, then you don't have to have the parentheses. But if you do not, you have to, because it will only divide this one and multiply the rest if you don't put it in parentheses. Or 10 times 9 times 8, 7, 6, 5, 4, and then 3 will stop. Okay, so this one will go 3, 2, 1. I don't need the 1 because 1 times anything is 1. This is 2 times 1, which I don't need the 1. Same thing there. The 3 factorials cancel. 3 times 2 is 6, times 2 is 8. No, it's not, it's 12. I can't use that. 3 times 2 is 6. So I'll cancel a 6. And then 2 is into 4, 2 times. So then you could multiply 10 times 9 times 8 times 7 times 5 and times 2 and get 50,000. Or you can plug this into your calculator. Most calculators have the factorial. Did it come up?
Yeah.
Yeah, it's nice when you have that fraction. What button did you hit?
I always use, like, I never divide, I always.
So that was alpha and
Y
alpha.
equals, yeah. Remember like factorial, you know that.
Right, that's under math.
I think you could do combinations and combinations.
Yeah, they were right there. Okay, so if we wanted 5 choose 2, you put
Yeah.
the 5 first.
I also get out of this.
And then go to math. And then whichever one you want to. And then 2.
Yeah. That's fine.
Any questions on that? Any questions on your calculator?
So you know where they're at. So, just all kind of piece. Okay,
So there's your. Now, to do that, to do the factorial, 1 in 10 factorial, you did the number first. Probability. The third one. Or like the permutation, if it was 6 choose 2, you put the 6 first. Then the probability, you want to put proportion, and then put the other numbers. Any other questions on your calculator? It's important because I mean, I don't want you working all these out. I mean, I can, if I want you to do one of these, I'll just put a problem up there written like this and you'll have to do it. But when you have combinations and permutations and a lot of probability, you want to use your calculator. So keep saying combination, but we haven't talked about it, at least in here. When you have a combination, order doesn't matter. So if I was picking 3 people to do a presentation today, The order doesn't matter, it might matter to you, but the order doesn't matter to me, who does it in what order. And so that makes it a combination because the order doesn't matter. And your numbers will be small. One way of showing the difference, permutations and combinations, I took the letters A through D and I paired them. When you're talking about a permutation where order matters, A, B, and BA are different. President, vice president, the order is different. It's important. That's a permutation. So all of these would be possibilities. But if I make a combination where order doesn't matter, AB is the same as BA, that's getting rid of half of them because of all your pairs. When you're talking about more than just two things that you're picking, it gets rid of even more than that. So it takes out all the duplicates, putting them in a different order. Because then order doesn't matter. A, B, C is the same as CAB. It's the same as BCA, BAC. So you would be getting rid of all these duplicates because that's the same as ABC. So hence another rule. What we're doing is, notice the difference in it. Here's the one rule. It's just the R factorial. So it's the same rule, n factorial over n minus R factorial, and then we're dividing by R factorial. This is taking out all the repeats. There's more than just these three, I didn't write them all. But it's taking out all the repeats. Should be 6. ABC, AC, C. So all of these would be the same thing. That R factorial is taking out the duplicates and leaving one. So every time you read one of these problems, the first thing you want to think of is, does the order matter? If it does not matter, it's a combination. If it matters, then you have to look at how many there are. Like if there's pairs that are duplicates or not. How many combinations, oops, this should be filled, for 4 objects taken 2 at a time? Doesn't matter how many we're choosing. I mean, the order doesn't matter. How many objects? 4 objects. So 4C2. Now, if you have your calculator, use your calculator, figure out, I should have brought my calculator today. My calculators. If you're using the formula, I'm working it out. Oh, air conditioning is off. Heaters are on. It will get hot in here. This room is one of the worst. Yeah, and they turn it all the way down to 55, which is bad because then it just makes it run. Plug this into your calculator, learn how to use it, make sure you're getting the right items. 4 times 3 times 2. So that 2 will cancel. This one will go into the 4 2 times and give you 6. So if you, in your calculator, when you're using this, oh, I don't want to write it. You hit the 4 first. And then go to the button that has NCR. And then 2, and then hit enter. Some of them will just put the C, and then you put 4, 2 and hit enter. Does everyone have a calculator that uses it? It's on there. Did you find it under probability?
This one?
Mm-hmm. Yeah, because that's the one I have. But I didn't know it. But you should have a button, PRB. Right here. And then you choose which one. If you do need to buy a calculator, don't go buy an expensive calculator. Well, unless you're gonna use it. I love my calculator. I use it for everything, including bills. This calculator. It's $17. Go on Amazon. I got I got them for $5 to $10. So this calculator here is a nice one. Before school started, I think it was $7.99. Everything jumped. But it's a nice calculator, and you should be able to find it on Amazon a lot cheaper and in really cool colors. Also eBay. I'm so used to Amazon just popping up on my computer. That one's a little different. So wow, they did jump. Here's one for 16. Or go on eBay and buy a used one. But in class, you can always use mine. Also, the Math Center has calculators you can borrow. It's on the 4th floor. I don't know that you can borrow them a whole semester, but like for the day if you needed them to do your homework. Another thing that's good, if you're working on Alex, on campus, you can go to the Math Center, you can work on it at one of their computers, and when you have a question, you raise your hand and they come over and ask you. They help you. You could also text me while you're doing it, as long as I'm not in another class, I can help you. Any questions on that? You, on eBay, you can buy bulks of them. So if a couple of you go together and get 3. Okay. Let's try it. The owner of movies at the park must pick 4 movies from a total of 10 to show at movie night. If the order the movies are shown in is not important, how many different ways can the selection be made? So he's picking 4 movies from 10 of them. Order doesn't matter, which makes it a combination. Cancel, 4 times 2 is 8, which cancels with the 8. 3 goes into 9 3 times. 3 times 7, 21, 210. We're getting 210.
Mhm.
But you can just use your function in your calculator. 10, and then it's under a probability somewhere. NCR work. Some calculators are C and then 10, comma. But either way, you're gonna get 210. The doing it the way we did before, where we're choosing 4 items, doesn't work when the order doesn't. If we went 10, 9, 8. We were choosing 4, right? So the first one we can pick from 10, then 9, then 8, and then 7. What's going to happen is it's too large. You need to divide by how many you chose. So you still could kind of cut stuff out if you wanted to, by doing the way we did before, but then remember, since order doesn't matter, I divide by how many I was choosing, factorial. But I think it gets a little confusing. Any questions on that? An office has 5 women and 8 men employed, and a committee of 2 women and 2 men need to be selected. How many different possibilities? So we have 5 women and we're choosing 2 of them. And then we have 8 men and we're choosing 2. You can do each separately and multiply them together. We don't want to use this because order matters here. It doesn't matter there. And what order we pick them in doesn't matter as long as they're on the committee. So if we're choosing from the 5 women, 2 of them, and the 8 men, 2 of them, you can do it like that. Getting 280. At least on my calculator, if I'm doing this all at once, I need to put them in parentheses. Then if I hit multiply, it's only gonna, yeah, you have to have parentheses. Any questions? Okay, 4.5. It's not really anything new. It's just throwing everything together. So let's try each of these. I want you to work it out first because that's what's going to happen. You're going to have everything thrown on it and then you have to try and figure them out. So let's look at the first one. Find the probability of getting 4 aces when 5 cards are drawn from an ordinary deck. Now we want probability, so you're not only doing like permutation or combination, if that's what you're gonna use. You need to divide by total possibilities because it's a probability. You want to think about your cards because there's 4 aces and there's 48 that are not. Order that we pick them doesn't matter as long as we get all 4 aces. So there's 4 aces, we're choosing all 4. Don't know. We could try it.
I don't know, I'm just.
The only thing is you're gonna have a lot of duplicates because the order doesn't matter. So we'll try it after. I know this one works. If there's 48, we choose 1. So when we're pulling the cards, 4 choosing 4, because that's our 4 aces. There's 48 other cards, and this is our 5th card. So one of the cards will not be an ace. Then you divide by your total, 52 cards, choosing 5. This is the total possibilities. If you calculate the top, you're gonna get 48. Because 4 choosing 4, there's only one way to do that. 48 choosing 1, there's 48 cards to choose from. Doing it the other way. I think that this will be too large. If we went, there's 4 aces out of 52, and then the next one, there's 3 aces out of 51. And then there's, and then we can pick any of them out of the 48. But I don't know that it's gonna give us if we reduce it. So reduce to Give me. Yeah, it won't work that way. So when the order doesn't matter. It's just easier to use combination. I won't ask. If I ask any of these, they will be on take home. They will not. Let's try number 2. A box contains 24 flashlights, because I know these are on. Has anyone ran into these ones yet on, out? 24 flashlights or some type of circuit. Twenty-four flashlights. Four are defective, which means 20 none. And we're drawing 4. Just like the deck of cards, you work the top and the bottom's the totals. So the first one, the probability 2 of them are defective. It doesn't matter when we're picking them, we're picking 4. So 2 of them being defective would be 4, choose 2. Because we're choosing, out of the 4 defective ones, we're choosing 2 of them. There's 20 other ones. And we're choosing 2 more because we're choosing a total of 4. So we divide by the total possibilities, which is 24 flashlights picking 4. Your probability is always the total. So for all of these, this will be your total. You should get, are you reducing them or leaving them? $1140 over 10,626. Or if it reduced, it's 190 over 177. So they're not too bad. You have your calculator calculate all this. You don't have to write all those factorials.
Okay, how do you model again? 24.
There's a total of 24 flashlights and I'm picking 4.
20 and 2. That's the one defective.
Yeah, 20 is not defective. So it said 4 were defective out of the 24, which means 20 were not. None of them defective. You only had one combination on top, right? Because we want to pick from the 20 that are not defective. We want all of them to be not defective. So on this one, we wanted none of them to be defective, so we were only choosing from the 20 that were not. And we chose all 4 from that. Any questions? So all defective means we're choosing all 4 defective ones. So on top, you're gonna get a 1, because there's only one way to have 4 items and choose them, so that comes out to a 1. This one has a lot of cases. At least one is defective means one is defective, and you can find that. Add it to the probability that 2 are defective. Add it to the possibility that 3 of them are defective. And then all of them are defective. It's only one case that's not in there, right? Rather than finding all those cases, we could take 1 minus probability none are defective. Because that's only one case. Here you'd have to do 1 defective, 2, 3, and 4. Then add them all together. Or subtract this one, and we already found it. Um, 1927 over 3542. Any questions on that? The lottery is always an interesting one. The state lottery has a person select a 3-digit number and repetition is permitted. Find the probability that all 3 digits are the same. This is one where you could get away without using a permutation and a combination if you think about it. A state lottery, you can have 3 digits and repetition is permitted. So how many ways can we choose the 3 digits? You're allowed to repeat. So when we choose the first one, 10. So there's 1,000 possibilities. How many ways are there that they're all the same though? 0, 0, 0, 1, 1, 1. How many are there? Those are the only cases where every single one is the same. There's 10 of them. So it's 10 out of 1,000. Or 1 in a. So if you're playing 777, then you have a 1 in 100 chance of winning. So technically, if you play it 100 days in a row, you should win once. Well, this is not saying the stuff, if you play all these doubles, triples, 100 days in a row, it should come up one of them at least in 100 days. So bet $1 on every single one of these for 100 days and it should hit at least once. But remember, doesn't mean you will. Any questions? I think the Ohio lottery is a pretty good thing. A drawer contains 11 red socks, 8 blue. Suppose you choose 2 socks at random in the dark. Find each probability. What you can do, the pair red, you can use the proportions. The probability that the first one is red, 11 out of 19. Oops, times. The probability of the second one, we've used a red, so there's only 10 out of 18. So 110 out of 342. Or reduces to 55. Same idea, if both of them are blue, because when you pick the blue one, 8 out of the 19, but you're not gonna put it back because you want to try and get a pair. So then there's 7 out of the 18, which gives us 56 out of 342. $28. The probability they don't match can get confusing. Like, first you have to do the probability they pull a red and then they pull a blue. Then you add that together with the probability they first pull the blue and then they pull the red. Or 1 minus the probability they have a match. So to find the probability they don't have a match, we can take 1 minus the probability they have a match. Should get 88 over 171. Any questions? So it's kind of weird when they throw all of them in together. And then some of these are a little tricky. I always try and find parts I know if I can do a 1 minus rather than finding all the other parts. Any questions? Are there any questions on Alex that you want to go over?
Actually, not yet.
Not yet.
Yeah.
Are you positive? Okay. My allergies are killing me today, so if you don't have any questions. But I do have a question. Some of these areas are going to start getting harder. For the second half of Wednesdays, when we have time, would you want to work on Alex? Would you want to use like 45 minutes on Alex? And then I'd be here and come around and. Okay. So on Wednesdays, at least the second half of the class, we will use on Alex. If you have some stuff you're working on, Alex, and have a question, I can help because we still have time. But if you don't have any questions today, I can just do it Friday.
Say, you forgot units here. Get your total. And then you're.
You have the rubric to take it.
No, I know, but like, isn't it that? So this is.
All right, that's all.
Thank you, because.
And I feel like you honestly.
So that's what
I feel like you should
Going down and you take.
go ahead and make my speech for my.
Yeah, I mean,
I just. I just finished.
she's like, years ago.
Well, right, so she.
Oh, what? The projects and
Oh.
communications.
So like I said, it's like once this last time on Friday, like I'm looking.
Well, she's such a quick, right? Today's until 1:50, right?
Have a good day.
Yeah, what about one?
Right.
It's fun.
Right?
I don't know what you. Well, we go 10 orally, so 140.
But if we're going by,
If we were given a 10-minute break, it would be 130.
We actually supposed to get one,
You're supposed to take a 10-minute break.
I feel like it should be really tell you them. And I didn't have my calculator, and so I'm just writing down notes until I get mine, because I left it at home, and I keep leaving it. I keep leaving it. Yeah, I have the text the extra, I've had it since 7th grade. I refuse mine. I love that thing. It's brought me good luck.
There you go.
It
And you should have it with you.
Did I get a bad grade on the test?
No. Did you have your calculator or used mine?
I use yours.
Yeah.
Either way, it's brought me good luck. I'm still talking good in my math.
Yes, you are. I thought you were talking about our project.
Oh, yeah, our project, right? It's on the.
Okay.
Yeah, I finished it. I just need to make sure my two brain cells weren't working against each other so that I got that grade on it, you know?
Yeah.
So I have to make sure I did it right.